So I think everybody who's, oh, actually Nathan, I've got some homework for you here somewhere, I think. No, maybe I don't. Thought I saw your name. Anyway, I've got some homework to hand. Oh, there it is. So I've sent some of you who either have not done any homework or at least a month behind, I mean not a month, but a chapter behind, have sent you an email. And basically what it says is that I'm giving you till the first class after the spring break to get in all of the homework from chapters 10 through 12. I'm going to go ahead and give you a 0 for that homework. And I also basically told you that it's very unlikely that you would get a C in this class or better if you don't do a reasonable amount of homework. So the withdrawal date for the class is March 21st. So if you haven't gotten your act together by that time, you might seriously think about dropping the class, and because it shouldn't be a surprise that you might fail the class or get a D if you don't do any homework. So anyway, not everybody got that message, just the people who are not up to date. Secondly, there are a few of you that have not taken test number 2 yet, which you were supposed to have taken by yesterday, but I'm not going to fail you yet. If you didn't take test number 2, you need to go and take it in the library by the end of the week. I have pretty much finished grading the test, but I'm not handing it back today. I'll hand it back to my Tuesday, Thursday class tomorrow, and then I'll post your grades so you'll know what your grade is before the weekend. It's just I'm not handing it back till Monday. Anybody have any questions about any of that at this point? On Monday, we're going to actually do a lab. I sent you an email about that as well. So we're going to do some spreadsheet stuff. So we'll go to room 409, which is the computer lab that's towards Backles Hall. So just bring your body and make sure you know what your password to log on so you can do that. I think that's pretty much it. I will give you your Chapter 12 assignment before break. I'm not sure when it's due yet, probably after break, but I know it'll be after break, but I'm not sure exactly when. So we were talking about section 2, which were measures of central tendency. The main one that we use is mean. We also use median, which we'll talk about here in a second. But before we do that, we talked about a weighted mean, and the usual example of that that I use is grades. So we looked at that last time. You know, each number for each category is based on a 100-point scale, but you don't just average the numbers together. You have to weight them according to their significance. Another thing that we are going to look at is calculating the mean from a frequency distribution. So in the first section, we learned how to create a frequency distribution. But let's say somebody else has created a frequency distribution, but you don't see the raw data. So you don't have the raw data to calculate mean from. So how do you do that? How do you calculate the mean from a frequency distribution? And well, basically what you do is you assume that all the values that are in a class have values that are the average value for the class. So I've got a set of data here, and what this represents is like we did online. This would be 105 and less. So in the terminology that we've used previously, it would be 100 to 105. this one would be greater than 105 but not equal to 105. Actually, I think I'm going to do it as an inequality. You guys have seen inequalities, even though I wouldn't do this on the graph just because it would be too much space. But what we're talking about here is we're talking something that's greater than 95 but less than or equal to, 100. The width is 5. So it would be greater than 100 but less than or equal to 105. Then you'd have greater than 105, less than or equal to 110, greater than 110, but less than or equal to 115, and so forth. So I'll just write these out. I don't need to keep talking about it. So they all fit the same pattern. By using this terminology, I'm being very explicit about that there is no overlap. Okay, so that's what they really represent. So, this is everything up to 105, including 105. This is anything greater than 105 to 110. So if you take the average of those, even though it's not exactly equal to 105 in, say, the second class, it's 105.0000. So if you take the average of the numbers that define the beginning and end of the class, you'll get the numbers in red. So we're going to use 102.5. Now, those 5 points that are in this class could all be 100, or they could all be 105. We don't know from this information. We've lost that granularity, that's the word, granularity to it. But, overall, most of the time they're going to, someone might be greater than the average, greater than 100, greater than this number. They might be less than that number. But average, overall, the more points you have, the more likely it's all going to work out. So the calculation using these numbers to get the mean is you take the average value in the class times the number of data points in the class, and you do that for each one of the classes. So the first class had an average value of 102.5. There were 5 data points. The second class had an average of 107.5, and there are 10 points. And you do that for all of the classes. And then you divide by the total number of data points. So you add 5 plus 10 plus 14 plus 15 plus 4 plus 1 plus 1. And the result, you get 113.5 if you do the math. And if you look at, once you have that written down, if anybody's going to write it down, the 113.5 is not going to be exact, but it's not going to be too bad either. It's probably going to be in the class that has the most number of entries, most likely. We'll look at it in a second. Just trying to think of anything to. I watched about 5 minutes of the speech last night. He did stay on script, which is good. But it's interesting, the Affordable Care Act, which is not perfect, it's not great either, but I'm not going to say it's the most wonderful thing in the world, but and if the Republicans come along and make it better, I'm as happy as anybody. I don't want them to have disaster. So it'll be interesting to see what comes out of that. It is a very complicated situation, which apparently President Trump has now figured out after listening to various people's sides, like people in the insurance industry and the healthcare industry, and doing this affects that, which affects that. There's always these secondary and third order things that so it's easy on the campaign trail to say, I'm going to repeal Obamacare because it's terrible. And maybe it was terrible. I don't know if it's terrible, but the intent was good. So at least he's realizing that that's the case now. So he's making progress. Okay, so let's go back. 113.5. would be in this class, which actually is, you know, it's not exactly the one with the most in it, but these basically have the same value. So it's pretty close. Okay, so that's how you do find the mean from a frequency distribution. Now, if you had the original data, you just take the mean of the original data. So, okay, the second important measure of central tendency is called the median, and it's pretty simple to do. If you have a spreadsheet, it's more difficult to do if you don't have a spreadsheet, because the first step is the hardest step. That's to go through a list of numbers that are not necessarily in numerical order and put them in numerical order. And once they're in numerical order, all you have to do is ask the question, do I have an odd number of data points or do I have an even number of data points? If it's odd, you do one thing. If it's even, you do another thing. So I'm just going to make up a very simple example. I'm just going to make let's see, we'll have 7 numbers. So let's do 2, 7, 11, 6, 4, 8, 12. Okay, so there's my list. There's 7 numbers. So the first step would be to rank the items in numerical order. So since there's only 7 numbers, that's pretty easy. At least hopefully I better make sure I do it correctly so it don't mess up. Okay, so there they are. When you have 200 numbers, you know, much more difficult to figure out which one's the next one. It's like alphabetizing something. Same thing. Okay, just doubly checking that I did that correctly. Okay, so it says if the number of data points is odd, the median is the middle item on the list. Now what I'm going to do is I'm going to put a number under each one of them, which represents, you know, what order they're in. So this is the first number in the list, this is the second number, third number, fourth number. So this is just it makes it easy to figure out. In this case, you know, it's not hard to find the middle number, it's 7, but how would I do that with a big list of numbers? So I'm going to prove it, show it with a small list, and then we can apply that rule. So what you can see is if I take I have 7 numbers, so if I take this number 7, so it's not the number 7 in the list, it's the number of data points 7. If I take that 7 and I divide by 2, I'll get 3.5. And then what you do is you round up, which doing that would give me 4. So the median is the 4th number in the list. So I'm not going to list numbers, but let's say I had 79 numbers. What's the number? What number do I use? Which number in the list if I assign each number in the data a sequential number based on its order? Well, I do the same thing. I take 79 divided by 2, which is 39.5, I think. Yeah, 39.5. Round up to 40. So the median is the 40th number in the list. So that's easy. Okay. So you don't even need to know what the numbers are. You just need to know how many numbers there are. Divide by 2. It's always going to, with an odd number, it's always going to be something and a half, so you round up to the next one. And so if I took these 79 numbers and I ranked them numerically, and I put a little number under each one, you know, the lowest would be 1 and the highest would be 79. All I have to do is just go along to the 40th number and look up, and that would be the median. Okay, so let's do the same thing for an even number of data points. So let's say we have 8 data points. So I'm going to use some decimals here just to be contrary. One, two, three, four, five, six, and let's see what else I need. Okay, so there's my 8 data points. So first thing you do is you order them according to magnitude. So you get 2.5. It's a little harder when you have decimal points. 4.7. So I can put a check, or I can mark through them just so I take into I don't worry about it. Okay, 5.4, 6.9, 7.2. How many is that? Did I miss one already? 1, 2, 3, 4. I need one more number. It's only 7. Let's say 8.2. Okay. Okay, so 7.2. The next one would be 8.2. The next one would be 10.5. And move over a little bit. And the largest number would be 13.4. Okay, so those are now listed numerically. And again, I'm going to put numbers below them just to represent which number they are when you order them numerically. So there's 8 numbers. So in this case, if you just look at this small list, you'll notice there is no middle per se. There actually are 2 numbers that are in the middle. The middle is actually right there. You've got 4 numbers here, and then you've got the middle, and you got 4 numbers on the other side. Well, obviously we can't just use the arrow. You have. So basically, what we do is the median is the average of those 2 numbers. So for when you have an odd number of data points, the median is just you pick a number. When you have an even number, you have to average 2 numbers together. So I'm going to say the median. Well, let's not. So what's the rule here? Well, if I took 8 numbers, I'm taking the number here, the number of data points. If I take 8 divided by 2, I'll get 4. So instead of rounding up, it's an integer, so I don't need to round. So since I got 4, so the median is the average of the 4th and 5th numbers. So that's going to be 6.9 plus 7.2 divided by 2, which is going to be 7.05. So that's my median. It's not a number that's in the list, but it is halfway between the 2 numbers that are in the middle. So that's how it works. And if you had, again, if I ask the question, I've got how many data points? I've got 150 data points. What numbers do I average? I average them because it's an even number of data points. So you take 150 divided by 2, which is 75. So I average the 75th and 76th number. And that gives me my median. So I made up the rule based on a small number of data sets because it was easy. And then I said, okay, I can apply that to larger numbers of data sets. Now, what do you remember about when would you think of using the mean for a central tendency versus a median for a central tendency? Does anybody remember that from previous classes? Because if you have what's called a normal distribution, they should actually be about the same number. So there's a lot of times they are the same number. So the answer is, since nobody's ready to give me an answer, is because if you have some points that are what we would call outliers, meaning that they're much one or two numbers is much lower than the rest, or one or two numbers is much higher than the rest, then your mean can be influenced by those outliers, whereas a median is less influenced by the outliers. Okay, so that's the case sometimes why median is a better measure of central tendency than mean is outliers. And mode is the data set which value occurs most often. Now that's the least useful measure of central tendency. So if you have two numbers that were 63 and all the other ones were different than every other number, then that would be the mode, because you have two numbers that have the same value. So they have to have exactly the same value to be counted as multiple instances of them. So if you had 79.2 and 79.1, those would not be considered the same number, even though they're very close to each other. So what I'm going to do next is I'm going to take this set of data, and I'm going to we're going to calculate the mean, the median, and the mode. Mean, median, and we're going to do a histogram. We're not going to do it by hand because it's hard to even just read those numbers. I wouldn't want to have to rank them, so there's no point. There's no reason for anybody to do that anymore. So I need to get it into a spreadsheet somehow or another. So let me just show you. So you might say, oh, okay, I'm going to open up a spreadsheet. So let me do that. I'm going to use Google Docs today. So let's see here. Right there. So remember, to get into Google Docs, and we'll do this on Monday again, is you sign into your Blackboard account. And then you go to Gmail, because that's all your Google apps. And you see all the mail that I get is me posting YouTube videos. Congratulations. That's to build up my sense of self-esteem. I keep getting congratulated all the time. Okay, you go to Sheets, and this is what we'll do our project in. So just pay attention. There's no way you can write down everything, but you'll get practice Monday, and then there'll be a video explaining how to do all this stuff. So you might say, well, I wonder if I could take the data. So what I'm doing right now for you guys online is I'm just going into my smartboard, and I'm copying this data. And if I come back over to the spreadsheet, so here I am again, and I paste the data. Okay, doesn't like Control V. Okay, so I do Control V. I get my data, but the problem is, what's my problem? It's all just in one cell, which is no good. So I got to do something else, right? Part of actually using Excel for data is figuring out how to get, instead of having to enter the data in manually, is to get it to do it automatically. So apparently that's not going to work, which I knew already, of course. Okay. Okay, undo. There we go. So let me show you what I'm going to do. There is a program, and you won't have to do this for your, what I will do is I'll provide you with a data set that you'll upload. So you won't have to create this, but I'm just giving you kind of an insight into what's going on. Okay, so now I need to share my notepad with you guys. Has anybody ever used Notepad? Did you even know it existed? Yeah, it's kind of like the rudimentary word processing thing. I mean, you could type stuff in there, but there's not a whole lot you can do with it. So I'm going to do my Control V. So there's my data. It's still in one big line. It did put a little, what do you call that thing? Quotation mark. And I think there might be one at the end too. No. Okay, so now I don't have any. All I've got is numbers with spaces in it. So I'm going to save this. Save as. So I need to put it somewhere where I know it is. I think that's the one, so I'm just going to save it again. So it saves it as a text file. So that's telling you what kind of formatting it has. I don't know what kind of formatting a notepad. Okay, so I've saved. Oh, see it. Yeah, replace it. Okay. So and then I'm going to close my notepad. So let me go back to my spreadsheet. Okay, so we can close Notepad now. So if you go to File, Import, so you can have your import, the file you're importing from is not going to necessarily be an Excel file. It can be a list of numbers, and the list of numbers could be in a column, they could be in a row with spaces in between, they could be in a row with commas in between, they could be in a row with tabs in between. There are different ways of formatting data. So if I click Import, I need to find the file. So my drive, where is it? Yep. Let's see, where is it? My drive. That's what I want to look at. I already did that. Select. Okay. Let's see what there is. Well, how do you go up? I don't remember having a problem with this before. Let's see. Okay. I'm assuming this will be it. It's not the same one that I did, but I think it's the same bunch of data. So it says you want to create a new spreadsheet or insert it into a new sheet, replace data starting at the selected cell. That sounds good. And you can use a tab, a comma, custom. I think the last time I must have used. So I'm going to put a space there. Hopefully that'll work. We'll see what happens. Hopefully it's going to work. I think last time I did this, I used Excel, which I'm convert text to numbers. Okay, let's see what happens here. There we go. So it did work. Thank goodness. So now each data point is in the cell. So that's what I was trying to do. Okay. So I've got this list of, actually this is a different set of data, but it doesn't matter. So the procedure is the same. There are actually 200 data points. I don't know what happened. That bothers me. Just let me try something again. I don't know. How about this? Does this work? What I'm looking for is the folder that goes back to. I want to go back into my other files, but it's not letting me do that. I don't know why. You'd think I could get to my files shared with me, recent. Huh, that's weird. Okay, I still don't know why it's not working. So, actually, I have a way of cheating here. I can put it in one of these files. Physics homework. Okay, let's see if I can find that. Oh, that's actually Google Doc files. That's what the problem is. That's why it's not finding it. This is my drive is in my Google Doc upload. That's what I need to do. Huh. Okay. So now we're cooking. So when it said my files, it meant my Google Doc files, which I didn't have that many of. So I'm going to go into my go in here, 152. I think I saved it somewhere here. It was in chapter 12. Let's go there. There it is. Okay. So there's my data. Open. detect automatically. I guess I'll try that and see what happens. I'm actually going to create, yeah, we'll just put it in here and then I'll erase everything else. I don't like to be beaten. Okay. Oh, see, it didn't stick it in a cell. Okay, that didn't work. Let me try that. Undo. Okay, let's try it again. Actually, what I'm going to do first is I'm going to delete all this data so I don't have it hanging around. Okay, let's try it again. File, import, upload. And then here, test, open, custom. So I'm just going to put a space in there and hopefully that works. Import. Import. What's the matter? Well, it says it worked, but it doesn't look like there's any numbers there, so that's strange. Okay, let's try it again. Import. Here it is. Select. Replace data starting at selected cell. Maybe that was the problem. Custom, put a space in there. Import. Oh, well, it did import it, and they are in different cells, but they're in a row. Anyway, you don't have to worry about it. I'll take care of all this. You'll just have to import it. It won't be. It's just I wanted to. Okay. I want them in a column, not in a row. Okay. Paste special, transpose. There we go. Okay. Now we go. Now we're moving. Delete rows. Okay. So there's my data. I finally got it into the spreadsheet. Usually the defaults are, as you saw, a comma or tab. Space is more unusual, and that's why we had a little bit of a problem there. So those are my data points. I have 47 data points. So to do the mean calculation, I'm going to do it first using the basic equation. And the mean would be, you would add up all the numbers. So the function is called sum. So we do equals sum. And then I highlight the data points that I'm adding up. So you highlight them, you do another parenthesis, and then we're going to divide by the number of data points, which is 47, and I get a calculation. So my mean, this is my mean. Just adding the numbers together, dividing by the total. There's also a built-in function which is called average. So instead of me having to do a little more complicated expression, I just have to put the function in, and I should get exactly the same number. So the mean or the average is 133.5. So you'll do that for your project. You'll calculate the mean. Okay. The next thing, I'm going to sort the numbers. This is so I don't have to go through and manually organize the numbers from smallest to largest. And all spreadsheets have this function. And in Google Docs, you go to Data, and you sort it, and you can sort the column, which is column A, that I've highlighted, and it says A to Z. Well, I have numbers, so when it sees numbers, it'll sort from smallest to largest. If I did Z to A, it would sort from largest to smallest. So there you go. That's my data from smallest to largest. Notice the mean didn't change because they're the same numbers. It doesn't matter what order they're in. Now, if you remember when we were doing the mean with those 7 and 8 numbers, what I did was I put a column here with the numbers, which actually correspond to the cell row, but I'm going to go ahead and put them in anyway. So Another nice thing about spreadsheets is if you want to put in a lot of numbers that are all the same distance apart, you put the first two numbers in. So I start at 1, I'm incrementing by 1, and so when I copy those two cells down, it'll list all the numbers. And I didn't quite get there, so 47. So you see there's 47 numbers. So what was the rule? When you have an odd number of data points, you divide by 2. So 47 divided by 2 is 23.5. You round up to the next number. So the median is the 24th number. So all I have to do is take my cursor up here to row 24, and I can say the median is 122.7. So it's a lot easier to do it by computer if you order them. The nice part is just ordering them. Now, there's also a built-in function which is called median. And all you have to do is just highlight the cells that you're trying to get the median of. You don't have to order them. It doesn't matter what order they're in. It'll do all the hard work. So if I highlight those cells, it says take the median of the numbers between A1 and A47, and I should get the same answer, which I do, because this is just doing it internally to the computer. This is me manually looking at the list. Okay, now, if I had an even number of data points, then I would take the average of the two middle ones. So let's do that. I'm going to add one more data point. Well, actually, easier to subtract one data point. So let me just go down here and get rid of this data row. So we'll cut that out. Control X. Okay. It doesn't like Control X. Edit. Move row up. Okay. I actually just did that. There's still, well, that didn't work. That was a bad idea. Okay. I'm just going to put spaces there. Okay. So notice the means don't match up anymore, and that's because I need to change the what was used to calculate them. There are only 46 rows now. So once I fix all those, this one is okay because there's no number in 46, so it just, or 47, so it just does it correctly. So now the means are correct again. Now, again, what I do when I have an even number of data points, what you would do is you would you take 46 and you divide that by 2, which is 23. So the median is the average of the 23rd and the 24th entry. So I go up here to the 23rd and the 24th, those two numbers. And so to calculate it now, it's not just one number, it's equal to the average of these two numbers. And I get 120.75, which agrees with the calculation. This already automatically updated it because when I deleted that one row, it just left a blank. If I put 46, it'll be giving the same number. Okay. So again, I want you to understand what median is, but in the long run, if you were doing this as a living, you wouldn't do that. You just highlight the data and type in the function median. It would do it all automatically for you. But it's the middle number in the list of numbers if they are ordered sequentially. And again, it's when you have outliers that the median is better than the mean. The last thing we're going to do is we're going to do another histogram since we have the data. So remember what we did with histograms. You have to pick out your class. So we'll take two of the numbers and we'll figure out what the classes are, and then we'll come put it back in here. So the smallest is 11, so 0 sounds like a good bottom number. And the high number is 272. Okay, so let's go back to So I'm going to have 0 and 272. We actually had something other than 0, but it's close to 0. So now we have to break that into classes. So let's see if you guys can come up with the classes without me doing it. So the goal is to have 5 to 7 classes, and they are the same width. So they could be 10, they could be 20, they could be 30, something. They could be 12.7, but normally you wouldn't do that. You typically pick class widths that are, so just try the first 3 and first couple. And again, remember what I did last time is you took the difference between these two, and if you divide by the number, like you could divide by 5 and 12 and see what those numbers are, and then you could pick something between those. So divide it by 5 and divide it by 12, and then hopefully there's some number between these two, which is something like 10, 15, or 20. And that would be a good choice for your class width. So let's see what you get. Get your calculator out. So what's the first number?
44.
Yeah. 54. 54.4, and by 12 it was 22. Yeah. So 54 and 22. What do you think might be a good number between 54 and 22? So obviously 10 is not going to work. 20 is not going to work. So what do you think? 30, 40, 50. One of those, probably. You could choose 25, maybe. That would give you. Would you say it was 22? Yeah. Yeah, 25 might be good because that's a multiple of 100. I mean, it's 20. 100 is a multiple of 25. So it really doesn't matter. You just kind of have to choose something. So again, this was 22 something. This was 52, 54. Oh, 20. What was the first one? Oh, 54, and this one was. Yeah. Oh, the opposite. Oh, yeah, I see what you're saying. Yeah, you're right. Yeah, I was like, I don't want. What are you talking about? No, okay. So this one's a 22.2. This is a 54. Yeah. So the number has to. It could be 50, 40, 30, 25. 25 is going to give you the most classes, and it's 47 data points. So that's a reasonable number of data points. So I would probably go with 0 to 25. 25 to 50, 50 to 75, 75 to 100, 100 to 125, and so forth. 125, 150, 150, 175, 175, 200, 200, 225. We're probably going to have 11 or 12 classes. And again, the only reason I'm doing this larger number of classes is because we've got a fair number of data points. And again, you wouldn't have them, one would be up to 25, including 25, and the next one would be greater than 25, but less than or equal to 50. So, okay. So now that we figured that out, we can go back to our spreadsheet and put that information in. So I'm going to put my class information here at the top. So I'm going to pick 25, 50, and that's all I need to actually enter. I'm going to then copy these two cells, which will now populate it with the remaining numbers. And I purposely went a little further than I had to because it's easier to delete than to add. So So that's my classes. This says 25 or less. This says 50 to 25. So with my data, with my class, now I can go to the add-on for this. Now, we'll do this on Monday so that everybody gets this add-on included, but let me just show you how this works. If you go to Get Add-ons, there's a whole bunch of different add-ons you can use that Google or somebody else has provided. The best way to figure out which one to use it would be just type in something that you're interested in. So if I type in histogram, which is what we're going to do, histogram, you'll see it comes up with a number of different choices, and some of them I haven't looked at before, like this one. This might be interesting. Let's say you wanted to do mortgage, something to do with mortgages. Except, how do you spell mortgage? Apparently not that. Search internet, mortgage. Well, that is the right way. Okay, I would have thought there would have been something. Let's see what else. Let's go back here. Oh, I didn't mean to do that. Okay. Don't worry, my spreadsheet's still there. It's right there. No, that's not the one I wanted. Okay, let me go back here. Oh, this must be it. Untitled spreadsheet. Okay, thank goodness that didn't lose. But anyway, let's go back to see if there's an add-on that might. How about budget? There we go. That's probably a good one. Budget. So here's some of it. You can do a project sheet planning. You can something else. These are project plans. I wonder if there's anything about taxes. No. Accounting. Yeah. So here you've got all kinds of accounting stuff. Bookkeeper, bank reconciliation. Anyway, there's all these different kinds, and there's one, the one that we have that I'll put, that you'll add to your. Once you do it, it'll be on your Google Docs. You know, you won't have to do it again. So it's called Excel Minor Analysis Toolpack. So we push start, and then we just fill in the. Well, first we have to choose what we're going to do, which is the histogram, and then we have to input. So the way it works is you actually highlight the thing you're interested in first. So this is my data, and then you go over here and click, and it'll put the correct numbers in. Okay, so that's the input range. Oops, I didn't mean to do that. Scrolling the wrong way. Okay, so let's scroll back to the top. The next thing I need is the bin range, which is the classes. So I'm going to highlight the classes. I'm going to click that there. My output. Let's put I'm going to put my output on a new sheet, so it's nice and compact here. So we'll pick that thing and we'll go there. Might not like that. And yeah, see, it doesn't tell me which sheet I'm on, so I'm not sure how that's going to work. So I'm going to leave it in the other sheet just to be on the safe side. Okay, so we'll put it right here. There we go. So it's in cell E2. And we're going to put an chart output, and we say OK. That's it. And when you're done with it, you just close it. So what we now have is a frequency distribution. And so it's taken all that data that was in column A, and it's telling us that one data point is between 25 and 0. There are two data points that are between 50 and greater than 25. Between 75 and greater than 50 is 7. So that's my histogram. There should be a total of 46, I think, data points. Now, there's two things it does. It always does greater than the largest number, so I'm going to delete that. We don't need that. And if we scroll over to the right, you'll see it's done the histogram already. So that's the histogram. Wow, there's a lot that are greater than 275. That's interesting. That's kind of a weird looking one because it has a lot of numbers that are between 250 and 275. Now, notice the labels are not showing classes, they're just showing the lowest or the highest number in the class. So the way you would change that is you would just go over to here. It's using these numbers as the title. So if I put 0 to 25 there, and I put 25 to 50 there, and I'm just going to do all these so that the classes are more well defined. Now, they don't have to be the same for this thing to work. If we put numbers that were not an equal distance apart, it would still work. It's just the guidelines for doing histograms is that, but it's not going to tell you not to do it otherwise. If you do something slightly different, it's like your classes aren't the same width. They don't care. They're just going to use whatever you give them. And then the final one would be this, 250, this 275. And if I go back to my graph now, you'll see that now it has the actual ranges in there. So there's my histogram, very nice. I can go edit it. So if I click on the graph and then click on this little arrow, advanced edit, so I can make changes. And as you make changes, it'll be updated. So let's say I don't need a legend, so I'm going to get rid of the legend. So these are things about the whole chart. And then you have some menu items to do with the axes. So what I'm going to do with the axis is, I can change the title name to weight. I don't know what it is. I'm just making that up. You see it updates it. You can change the font, the color, all the normal things that you can change. The slant line, we can slant them at a certain angle like that so they're easier to read, so they're not smushed up. Sometimes you want to do that. And the frequency, so you might change your title. That's the title, axis title. If you wanted to change the title of the histogram, you go up here like that. Okay, once you're done, update. And you can actually move this to another spreadsheet. So if I moved it to its own sheet, there it is. So now it's by itself. So you'd have one tab with the data, which is right there. And you'd have one tab with the graph. And then you could send that to somebody, which you'll do for the project. So like I said, Monday we'll go through another example. Let you do it yourself. So I think we're done with section 2. So let me assign the homework. There you go. It's raining again. Okay, so that was measures of central tendency. The next thing we're going to do is measures of dispersion. And there's really only one way of measuring, there's only one way we're going to learn to measure dispersion. And you've probably had it before again. And what we'll do is we'll go through a small data set show you how it's done. One of the assignments for the project is you take a larger data set, use Excel to demonstrate how you do it, and then use the built-in command, which is very easy to use. So there's basically two ways. One real simple, which is called the range. You've had that before. That's nothing new. So if you look at the range, you just take the maximum value in your list and subtract it from the smallest value, and that difference is the range. The problem with the range is if you have outliers, meaning the end data are way different than everything else, then you can have a huge range, but you don't have as much dispersion as that would indicate. So the more useful one is called standard deviation. And it looks fairly complicated. The actual calculation could look fairly complicated, but it's really not. You just have to break it up into small steps. So you have a sample of data, just like we've used a sample of data to calculate means and medians. And that sample of data does have a mean. And what we're looking at is the difference. The main calculation is the difference between the individual data values and the mean. So if you take a mean, most likely half the data points, not always, but most of the time, or close to it, half of the data points are less than the mean and half of the data points are more than the mean. So this number, x minus x bar, half the numbers are going to have a negative that, and half the numbers are going to have a positive number. And if you actually add up all of these, you'll get 0. X minus x bar. That's just because the mean is exactly in the middle. So what we're looking for is not, so if we add them all, we get 0. That's not going to be very useful. So what we do is we square the number. The basic idea of squaring the number is to make it positive. So if you have -1 deviation, you square it, you get +1. If you have +1 deviation to the other side, this side, you square it, you get 1. We're really looking at how far away from the mean it is, not whether it's left or right. It doesn't really matter whether it's left or right when you calculate the standard deviation. As far as it matters, but in the calculation it doesn't matter. So you square those and you add all the squares together. And ultimately we want to take the square root because we want to get it back into the same units, the same scale as the actual numbers involved. So we end up taking the square root ultimately. But before we do that, we divide by the number of data points minus 1. So those are the steps. First you calculate the mean of the numbers. So that should be x bar, not just x. So calculate the mean. You find the deviation, which is this calculation for each number. Then you square the deviations. So you take that list of numbers and you square each number individually, and then you add them up to get a total. And then you divide that total number by the number of data points minus 1, and then you take the square root, and that gives you the standard deviation. So let's just let's do an example here. So I'm going to pick, let's see, 6 numbers. So my data consists of the set of numbers. Well, actually, I think I've got some on the next page. So let me just delete that. Yeah, so here's the 2 sets of data. We're going to do the same for both of these sets of data. And you'll find out they both have the same mean. If you calculate the mean of this data down here, it's 6. If you calculate the mean of this data, it's 6. So they have the same central tendency, but you can see there's clearly a difference between the sets of numbers. You've got, if these 2 are 1 above the mean, these 2 are 1 below the mean, the other 3 are at the mean. Whereas here, here's one number that is the mean. All the other ones are on either side. Half are going to be on one side, half on the other. Well, not necessarily, but they're going to have plus or minus deviations that are larger than these. Because we go from 2 to 11. Here we only go from 5 to 7. So we'd expect the standard deviation, which is the measure of the dispersion, to be higher for this than that, just from a qualitative standpoint. So we're going to do both of those sets of data, and then we'll see the numbers, and we'll say, yeah, actually that's true. So let's make a table up, and we have 7 numbers, so I'm going to make 8 rows, and we need 3 columns. So the first column is just the data. So this is X. So we have 2, we have 5, 7, 4, 7, 6, 11. And if we average those numbers together, got the mean, we'd get 6. If you add those numbers together, you get 42. There's 7 numbers. 42 divided by 7 is 6. Now the second column is the deviation. That's the difference between these numbers and the mean. So I'm going to show the calculation explicitly for the first few, and then I'm just going to write down the answers for the second bunch. So you take the number 2, you subtract 6. Here we take the number 5, we subtract 6 again. So that's -1. Here we take 7 minus 6, which is +1. So you can see this one should be -2, this will be 1, this will be 0, this will be 5. This is 5 above the mean, this is the mean, this is 1 above the mean, 2 below the mean, so forth. So then this is the deviation squared. So all we do is we square the number in the second column. So we get 16, 1, 1, 4, 1, 0, 25. So what I'm doing here is -4 squared. I'm doing -1 squared. And notice they're all positive because I'm squaring them. Now, at the bottom of this column, I add them all together. That's the summation part. So I'll take 16 plus 1 plus 1 plus 4 plus 1 plus 0 plus 25, and I get 48. So this just means add them together. So the standard deviation is equal to the square root of x minus x bar, the summation of that squared, divided by n minus 1. Well, the numerator is 48. So it's going to be the square root of 48 divided by the number of data points, which is 7, minus 1. So you get 48 divided by 6. Take the square root of that. You get 2.83. So the standard deviation of that data is 2.83. So if you look at the deviations, all these middle data points are either less than, if you take the standard deviation, you take the mean, 6, and you add the standard deviation, you get the maximum would be 8.8. If you subtracted it, you would get 3.2. So all these 5 numbers in the middle are within 1 standard deviation away from the mean value. This one's more than 1 standard deviation, and so is this one. But neither one of them is more than 2 standard deviations away from the mean. And we'll come back to what the significance of that is in the future section. Right now we're just saying the number represents how much dispersion you have. And really we can only compare the data between sets of data that are measuring the same thing. If you took the standard deviation of the width of a human hair versus the standard deviation of how much mileage a Honda Accord gets, they're completely different quantities, so there would be no point in comparing the standard deviations. But if you were comparing the width of hair of a person versus the width of a hair of a monkey, then there might be, then you might be reasonable to make that. Okay, so let's do one more here. So we're going to do the same size table. We're going to use our second set of data. Again, our columns are the same. And we go back and find the data. 5, 6, 7, 7, 6, 6, 5. 5, 6, 6, 7, 7. Oh, I messed up. 5, 6, 7, 7. Okay. 5, 6, 7, 7, 6, 6, 5. Okay, you add those numbers together, you get 42, and you divide 42 by 7, and you get 6. So the mean's still the same. So the deviations are calculated the same way. 5 minus the number minus the mean. So I'll get -1. Here I get 0, get +1, +1, 0, 0, -1. Okay. These two are one above the mean. These are two are below, one below the mean. These are the mean. And so if you square those numbers now, so if you take -1 squared, we'll get 1. So we square these numbers, you get 0, 1, 1, 0, 0, 1. So those are my deviations squared. And then if you add those together, you'll get 4 instead of 48. So now if you plug it into calculation standard deviation, we take the sum, which is 4, and we divide by 7 minus 1. And obviously we're going to get a smaller number than we did before. So take the square root of 4 divided by 6. You'll get 0.81. I'll just put 82. So that's the dispersion for the second set of data, which is what we expected. We expected, because these numbers were closer together, this dispersion should be less. And you can see this one has significantly more dispersion than that one. And again, looking at the numbers, we can see that's true. Okay, so that's how you would do it manually. So to do it using Excel, we just have to do the same thing with a lot more numbers. But the calculations are simple to do. So let's see if we can do this today, and we'll do it on Monday again with a new set of data that you'll do. So I'm going to do it fairly quickly, so you're not going to be able to, hopefully not so quickly that. So what I'm actually going to do is I'm going to copy the data first, just so I can put it on a new spreadsheet, new sheet, so I don't have. Okay, so there's my data. And I'm going to insert a row so I can put some headers on it. Insert one above. Okay. So this is my data, just like, or X. This will be my deviation. Deviation. I guess that doesn't look right, but I think it's right. And then this is deviation squared. So all we have to do is do the calculation one time, and then we can just copy it. So the deviation is, well, we're missing one thing. We need the mean. So if we go down here and calculate the mean, which I had on a previous page, but I don't have it on this page. So we'll say equals average. We'll highlight these data sets, these cells. Okay, so the mean is 128.1. Okay. And that, what cell was that? That was cell. Oh, this is a bigger set of data. Okay, it doesn't matter. Okay, 49, cell 49. Okay, so what we do is we'd say equals, and then we would put a left parenthesis. This is the X value, and we. I've already forgotten what it was. 49? No, it wasn't. It couldn't have been 49, could it? It went all the way down to, it was like 200 data points, I think. Oh no, it is 49. You're right. Maybe it is the same data set today. I don't know why. Now, one thing you have to do is put $signs here. What that does is it'll use the same number for the second because the mean doesn't change. So those are the deviations. Let's just go ahead and square it. So we take this number and we square it. We use that little hat thing. So that's the deviation squared, and then we can just copy this formula down all the way to the bottom. Okay. So these are my deviations. Half of them are going to be positive, half are negative, but all of them, when they squared, they're positive. So that's the third column. And then all you'd have to do is add those up. So I'm going to say equals sum, and I'm going to highlight all these cells. And so when I add all these deviations up, I'll get a number, 171,728. Okay. So now to calculate the standard deviation, I take the square root of the sum of the deviations divided by the number of data points, which is 46 minus 1. And I get that. That's my standard deviation. Whoa, that's too big. Well, maybe it's not too big. It seems too big. Now let's see what the computer says. The standard deviation of these numbers is 61.78. Is that? Okay, it just seemed big. So I think part of it is because there were a lot of numbers here that were in the 200 range that we had. That caused the standard deviation to be a lot bigger than it was. But you can see it's the same thing we just did. We calculated the mean. Then the deviation was the value minus the mean. Half the values were greater and half the values were less than the mean, or approximately. Then we squared this deviation, so these numbers became positive but squared. So they're bigger, but they're positive. Then you go down to the bottom of this column, you add them all together, and then you use the formula for standard deviation, which is the square root of the sum of the deviations divided by the number of data points minus 1. And as I just showed, there's a simple calc. You wouldn't have to do all this, if you could just use the formula. And that's what you would do normally once you understand what's going on. You would just use the standard deviation. You wouldn't go through this calculation. But I want you to do it at least once or twice so you know what it is involved. So that's the measures of dispersion. Well, there's another one, but we'll cover that. We don't need to worry. Everything we need to do on Monday we have covered. I'm going to go ahead and assign the homework from this section because there's not that much left to cover. So both of the assignments that I did today, those will be due next Wednesday. Remember, on Monday, we will meet in room 409, which is in Warren Hall. So you can go in the front door, go to the back, take a left. It's the last one before you go through the doors to leave again. You don't need to bring anything except know your password and username so you can log on to Google Docs. And we'll see you. Again, if you haven't been doing any homework, it's time to get going or leave the building because you're going to ask people who are taking this class again to do their homework. Usually the reason is because they didn't